Here's a calculus problem where you're expected to find a derivative, and in order to find this derivative, you have to understand the first part of the fundamental theorem of calculus and also the chain rule. First, I want to explain that just to plug a number into capital G, just to evaluate G at a specific value, you're going to be computing an integral every time. For example, just to plug the number 1 in, you're computing the integral from 0 to 1 of cos t dt. To plug 2 in, you're finding the integral from 0 to 8. To plug 3 in, you're finding the integral from 0 to 27. Every single time it's an integral. Notice how it's not 1, 2, and 3 up there. The x cubed means we're using 1, 8, and 27, so those numbers don't directly track. You can simplify these integrals for yourself if you like and substitute the values. You're going to get sine 1, sine 8, sine 27. We're in radian mode, so I don't know what those values are, but it doesn't really matter. The important thing, there are 2 steps. In order to find g of any value, you first cube the number and then you do the integral. 2 steps means chain rule when we're finding capital G prime. It's a composition. It's just hard to see because of the funny integral notation. So now, what I want to do is just lay down a real quick chain rule problem. Remember that you have to identify the function composition first. In this problem, first you have a polynomial, then you have ln. Some of you may be used to the vocabulary of inside and outside parts. X cubed plus x is inside, ln is outside. So to find the derivative, what you do is you find the derivative of the outside part with the inside function plugged in, and then you have to write a giant time symbol and multiply by the derivative of the inside function. So this is a very straightforward chain rule problem. This is actually what we're going to do for this problem right here. The inside function, step 1, is actually x cubed. Step 2 is finding the integral. And so g prime is going to be the derivative of the integral with x cubed plugged in. If we're really copying the other chain rule problem, we have to multiply them by the derivative of x cubed. Okay, well, this is where that fundamental theorem of calculus comes in, where it says that if you have an integral and then you take the derivative of that integral, you get back where you started. And so I get to just write cos of the function, cos of x cubed. The derivative of x cubed is really dead easy, so I just multiply it by 3x squared. And so this problem is literally finished. Now, very quickly, here's a second method that you could use to solve this problem. Really, you would start by simplifying the formula for g before finding the derivative. It can be done in these 2 steps. I can do this because cos t is such an easy function to find the antiderivative for. This is not always going to be possible, but it's possible here. So I find the antiderivative of cos t to be sine t. I evaluated x cubed and 0 and subtract, and then I find out that g of x really was just sine of x cubed all along. And so you can see that to find the derivative of capital G, you're going to use the chain rule. And the outside function is sine, and the inside function is x cubed. And so you're going to be multiplying these 2 derivatives together to get your final answer.